try to solve this question today. Basically, given an integers array nums sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. Okay, so we are giving a non-decreasing order array. So here if you see, every array is going to be sorted, and they're essentially asking us to calculate the squares of each element. So here in example 1, if you see, you calculate the squares of every element, it will be 16, 1, 0, 9, 100. And then they're returning all those elements but in a sorted fashion. Okay, so let's just consider this. Sorry, 1 second. Okay, now let's consider this array -4, -1, 0, 5 and 10. Okay, now one way we can do it is we can square every element. Here it's going to be 16, 1, 0, 25 and 100. And before returning it, right, we have to return it in a sorted way. So squaring of all these elements will be O of n, and returning it in a sorted fashion. Now we have to sort this array, and in order, if we sort this fashion, sorting will take O of n log n. We can do the sort by either quick sort or merge sort. Okay, so this is one way to do it. Okay, but you can see that the time complexity here is going to be O of n log n. So let's think of a way where we can reduce the time complexity to O of n. Okay, let's take the array again, -4, -1, 0. Let's consider 1, 2, 3. Okay, now let's take a result array. Okay, this result array is going to be this. Now one thing is that since this is a sorted array, we know that this is definitely sorted. So the element here, the square, when you square the elements, right, the element at this place will either be the square of this -4 or the square of -3 or the square of 3. And how can you figure out which one it is? You can just look at the absolute value. So the -4 absolute value is 4 and 3's absolute value is 3. And if you square these elements, you can see that this is going to be 16 and this is going to be equal to 9. And 16 is greater than 9. So the element at this place will have to be 16. Okay. And once we use this, right, this element is done. So I'm thinking we can use a two-pointer approach. Initially left was this and right was this. Okay, and now we use this element, and now we can increase left to here. Okay, and now let's compare the absolute value of -1 and 3. 3 is greater, so the element at this position is going to be the square of 3, which is going to be 9, and then r can be put here. And now what is the square? I mean, now you can just compare the absolute value of 2 and -1. It's going to be 4. R is going to be here. Now n and 1. Okay, so in such a case, when the absolute value is the same, we can just do either. So let me just say we're going to decrease the right pointer. We're going to take this. It's going to be 1. Okay, now we can see that this is greater than this. So this is going to be 1. L is going to be here. And this is going to be 0. Okay, so now we got the answer by traversing the array in O of n time itself. So we did reduce the time complexity. The space complexity, however, we're going to store it in a different array. So the space complexity will also be O of n. Okay, now let's try to code it out. Okay, let me create a result array. Okay, and this will be new int, and it will contain the same number of elements initially. Okay, now let me take 2 pointers. L is equal to 0. Let me take r is equal to nums dot length -1. Okay, and now let's actually start. Okay, we want to return the result array. Okay, I don't know why I did this. Okay, now for I is equal to n-1, I is greater than equal to 0, I minus minus. Okay, now what are we doing? Let's compare math dot absolute value of nums of L if the absolute value of the left side is greater than the absolute value of the right side. What are we going to do in this case? Then let's consider a take. Okay, in this case take is going to be, which element are we going to take in this case? We're going to take nums of L, right? But the answer should be the square of the element. So let's just take nums of L into nums of L. Okay, else take is going to be nums of R into nums of R, right? And we have to update the values of the pointers as well, right? Now we took the leftmost element, so now L plus plus. Okay, here we're not taking, here we took the right element, so R minus minus. Okay, at the end, result of I, which is the last element, is going to be equal to take, and this will go on till I is equal to 0. Let's see if it works out. Okay, looks like it did pass. Now let's submit. Yep, so now we were able to do this in O of n time. I think that's it for this video. Thanks everyone for tuning in. Bye bye.